Hello guys, I'm back with my next lesson. So still we are on 10-1 and we're simplifying trig expressions. So I have a few more examples to show you guys. So I'm on page number 630 and I'm looking at example number 3. So example number 3 and 4, that's what we're going to do today. So let me show you the first one. So today's lesson is more like when you use special patterns. When I say special patterns, so basically, I'm talking about difference of two perfect square, difference of two perfect cubes, sum of two square, or not sum of two square, sum of two cubes, something like that. So first, I'm just going to put those patterns up so that you can actually have those handy when you're using those. Like, let's say if the difference of two square comes in there, so it would be a square minus b square. This is equal to a minus b and a plus b. If it's difference of two cubes, so that was for squares. All right, perfect cubes. So difference of two perfect cubes, it would be a minus b, a square, b squared. It's ab, not 2ab, and opposite sign. Sum of two cubes, it would be a plus b. Then again, it's a square, b square, ab, and opposite sign. Here you go. And there's another one. I don't know if you want to use it. So let's say it's fourth root or fourth square of two, or difference of two perfect fourth roots. Let's just say that. Difference of two perfect fourth roots. Like let's say something like this. This could be a to the second minus b to the second and a to the second plus b to the second. This one, which could be simplified more, because I see another difference of two squares in there. So this could be simplified more as this. There's nothing for sum of two squares, so I would keep this one the same. So that could be another way to simplify. All right. Okay. Let's look at example number 3. I see secant squared theta minus 1. All right, so what I see is it's a difference of two perfect squares. So I could rewrite this as secant theta minus 1 and secant theta plus 1. Here you go. So I'm trying to show you how to factor out different expressions. So that's the first way if you see difference of two squares. Next one, if I have normal looking quadratic function like this, if I ask you to factor this one out, so I could do x factoring. So you can just pretend, you can just assume that this expression is just normal variable. Let's say this is x squared, this is just x. You could do that. You could rewrite this as normal looking quadratic function. Once done factoring, bring back the original variable. So this one would be negative 12. I have positive 1 here. So two numbers multiply to negative 12 added to 1. I have 4 and negative 3. Then I need to divide. If a is different than 1, yes, we divide. So divide by 4. Simplify. So my first factor would be x plus 1. Second one would be 4x plus 3. Bring back the original variable, so which is tangent. So it's tangent x plus 1. 4 tangent x plus 3. Here you go. I'm done factoring. All right. One more. So let's say I have sine to the third minus 8. All right. What I see is, oh, it's to the third power. Sine to the third, which is a perfect cube. And 8 is also a perfect cube. So let me just write their cube roots first. So sine to the third is a perfect cube of sine, 8 perfect cube of 2. I would recommend you doing this first. So find their perfect cubes, because basically once you have these perfect cubes, this original problem, pretend it's gone. It's not even there. So now let's follow difference of two perfect cube pattern. So first one, let me write that down. So it's a minus b, then a squared and b squared. So it's ab and opposite sign here. Here you go. So A is just sine, B is 2. So my first factor would be, don't forget to put theta. I always forget, but you don't, please. Sine theta minus 2. Second factor, so A squared, which is sine square, and B squared, which is 4. AB would be 2 sine theta, and opposite sign, which is plus. Here you go. I'm done factoring. So that's all for this one. Anytime it asks you to factor out the expression, once you have those factors in parentheses, you're done. All right. Okay, one more example. That's another on factoring, another one. I have cosecant squared theta minus cotangent theta minus 3. Oh, there's a problem. Normally, whenever it's factoring problem, you would see one trig function in an entire problem like this one here. What I see is I have two different trig functions. So first thing, you actually have to make it into one trig function. Either switch cosecant into cotangent or switch cotangent into cosecant. So whichever one is easier, you could do that. Now try recalling Pythagorean identities. So see if you could actually replace cosecant in terms of cotangent. So what I see is, if again, if you go back to those identities in three different ways, look at last column, so you'll find that identity. So as per that identity, I know cosecant squared theta is equal to 1 plus cotangent squared theta, which I would replace in the first equation. So I would take this whole expression and replace this function with that. So I would do 1 plus cotangent squared theta, and outside expression still the same. I have cotangent theta minus 3. Now simplify. I have 1 plus cotangent squared theta minus cotangent theta minus 3. Simplify, combine like terms. Cotangent squared theta minus cotangent theta. Combine these numbers, minus 2. All right. I still have to factor this down. So since I ended up getting a quadratic, so I could just do x factoring. So this is negative 2, this is negative 1, two numbers. I would say negative 2 and positive 1. Yeah, I don't need to divide because a is 1. So finally, my factors would be cotangent theta minus 2, cotangent theta plus 1. Here you go. So yeah, this is all. I'm done factoring. So pretty much this is all I have for factoring. So make sure you follow all these patterns. Depends on what you needed for that problem. And yeah, this is pretty much all. Thank you for watching. Bye-bye, guys. Stay